Hey, hello everyone. Welcome to the next lecture of this series. Yesterday we discussed about data lakes as an architectural pattern. Before that, we had discussed about data warehouses. Today we are going to discuss about a third architectural pattern, which was very popular during I think from 2018-19 to 2021 onwards. It was the data lake plus data warehouse. Okay, let's first try to understand the limitations of a data lake and a data warehouse, and why the world started shifting towards this data lake plus a data warehouse kind of a pattern. So if you remember, right, we studied data warehouse. What were its properties? Okay. Now this is mainly the structured, the traditional warehouse I'm talking about, or the on-prem data warehouse. And that time it was mainly for structured data. Okay, it was mainly for structured data. Nowadays, right, if you look at something like Snowflake, you can very well have semi-structured data. You can also play around with the unstructured data. So a lot of things are there. Things have evolved as a platform. But if you look at the traditional warehouses, the problem was, or the limitation was, it was only for structured data. It mainly supported your batch kind of a processing, right? It didn't really supported low latency, real time processing, or streaming kind of a jobs. Um, but at the same time, right, the good thing about a warehouse was it stored data in a well organized, well structured manner, so that you would get data that is organized properly, right, into a proper schema, table, columns, with all schema would be there, because these are all, the schema is already defined before you insert the data. So it is always well structured data, so governance becomes much easier here. Data quality, right, data quality is also much better as compared to data lakes. When I say much better, it is comparison is with data lake. We are trying to compare warehouse with a data lake. Okay, so data quality, data integrity, because of all the constraints, all the data quality rules, because of the structure, it was much better. Okay, it supported your BI, right? It was mainly for your BI application, so it gave some excellent performance. So if you have come from that era, right, where we use data warehouse for supporting large queries, analytical queries, aggregations, right, for your monthly reports, quarterly reports, especially in financial institutes, you know that these queries are very very complex, but warehousing systems supported this really well. But at the same time, it did not support AIML, right? There was very limited support, again, because unstructured data was not supported, right? AIML, it's all about unstructured data. You need a lot of large volumes of unstructured data here, so the support for AIML was limited. The next is, it was more of a proprietary, right? If you remember our discussion, the application, the software of warehousing, the way it stores the data, that is, it's all proprietary, right? It is not really open to the world how it is being done. So the storage is proprietary. You cannot really access that storage. Let's say you have put something in a warehouse like Snowflake, right? You cannot go and access it using any other engine. Okay, I'm again talking about when see Snowflake is a bit of an exception, right, because it's a more of a cloud data platform now. But traditionally, if you look at warehouses, these are proprietary. Storage is proprietary. You cannot do anything with it. So even today, right, if you put Snowflake using its native format, right, if you store data into Snowflake tables, not the iceberg table, just the Snowflake tables, you cannot really access it from outside without using Snowflake. So you have to use the Snowflake's compute engine for that. So this was all proprietary, and so in the end it can be vendor lock-in also, right? You cannot really access data from anywhere else directly without, let's say you want to use some other compute engine for Snowflake, that won't be possible if you are using its native format. So these were the typical data warehousing features, right? Some of these were limitations, right, like proprietary storage, vendor lock-ins, no AIML. These were the limitation. But what are the good things which were here? Let me highlight that. In data quality was great. BI support was excellent, right? It would do all these things. There was fine grained access control you would do, because it's a well structured data which uses catalogs, and all the schemas are present. So access control at a very fine grained level was easier. Okay, what do you mean by fine grained access control is where when you can control the access to a particular database, schema, or table, as well as at the column level. If you can do it at a column level, okay, or at a row level, then it becomes more of a fine-grained access control. So all these things were supported by a warehouse. Whereas on the other hand, right, if you look at data lakes, what are the good things and the limitations? So data lake supported all types of data, right? All types of data, as we have seen, not just structured, semi-structured, but unstructured also. So you could just dump all your data from the social media feeds, Twitter, Facebook, whatever, images, audio. You can just, that's a single storage for everything. uh, Data lakes also supported your streaming workloads, not just your batch but streaming near real time. All those things were supported by data lakes. But the problems here is, right, see, the data is not really well managed, it is not well governed. There is no schema. Sometimes we just dump the files, okay, dump the files into this, it becomes data swamps. What does that mean is, data is just dumped into the data lake, but no one is using it because you cannot really discover. Let's say if there is no catalog, there is no metadata layer on top of it, you are just dumping the files. People cannot really discover it. What's the use of data if it cannot be discovered, right? People, the business teams can only use the data if it is discoverable, if there is metadata, if they can go and explore it in the UI, if they can see what this data really means. If they don't understand that what the data is, it's of no use. So that was the problem with data lakes. But at the same time, because you could do structured, unstructured, semi-structured, it supported everything, BI to AI. So AI ML use cases were possible because of this, right? AI ML was possible. Why? Because unstructured data, because AI ML needs that kind of data, data lakes support that. But when we say BI to AI ML, see, BI is fine, but then you won't get the performance, right? Performance was an issue. You won't get that kind of a performance because the kind of performance your warehouse provides for your BI workloads, you cannot get that with data lake. I think we did mention about this yesterday, right? Let's say you have source files, you have put it as a Parquet on on a S3, and then you are trying to run your Athena queries. You may not get great performance because this kind of a storage, right? It's a cloud object storage. It is not meant for that kind of processing until unless you do something else on top of it, right? That something else is the open table format, which we'll talk about later. But yeah, if you just try to just query a Parquet files without any metadata layer on top of it or the management layer of top of it, you may not get the great performance. So that was a problem with storing the data into data lake. uh, uh, so slow querying, slow BI queries, but at the same time, because it's a object storage, right? Commodity hardware in case of Hadoop and all, it is much cheaper. Okay, it is scalable in case of if you are using cloud data storage. It is much scalable. You don't have to worry about anything. It is not proprietary, so I'll put it as open. Right, you dump the data into S3. You can use anything else to access that, right? Any other engine you can bring in. You can have your Presto, Trino, Athena, outside world, right? If you get share that data, anything is possible. So it's not proprietary, it's open. So all these were the good things, right? So what were the good things? Open platform, okay, support for AI ML is there, all types of data including streaming. But problem is with BI performance is an issue. You cannot really do that. Not well governed, no access control. Access control again because there is no data catalog. If the metadata is not created on top of this, there would be issues related to fine-grained access control. So in data lake, right, you're just dumping the files. It is just the files. Let's say you don't create any tables, you don't give it any structure. No structure, so you won't be able to do any access control mechanism. So it's a coarse-grained access control, right? Here we said fine-grained, here it is coarse-grained at the object level or the file level. So you can just, this is S3, you can just say whether someone has access to that bucket or not. But if you don't create any tables, there is no fine-grained access control. So warehouses, there were limitations, pros and cons. Data lakes, there were pros and cons, and that is where the data world started moving towards another architecture which used both. Okay, which is when I say both, it is a data lake plus data warehouse. So I have used a similar kind of architecture in past, and I thought that time, okay, this is the best way to do the things. Again, this was before I think to 2020 2021. where lake houses were not that being used. Okay, not the adoption was not that much for lake house. So it was before that. Okay, so far we discussed about data warehouse as a storage. We discussed about data lake. Now we are talking about data lake plus data warehouse. Okay, this is not a lake house architecture. Okay, lake house is something else which we are going to cover. So that time, right, before the lake house concept was coined, sometimes this kind of an architecture was also called as a lake house. So lake and house, these were two different terms. Okay, it was called as lake. I remember AWS had this concept called lake house. Okay, for especially with Redshift to build a lake house. Okay, there were I believe articles for that. So what does a lake house here means? Or let's to keep it thing simple. Okay, not to confuse anyone. Let's say data lake plus plus data warehouse. So what this architecture had is simple. You will have two storage tiers. One would be data lake, the other would be data warehouse. Okay, so why do you need these two storage tiers? So source data will come from here. You will ingest it, put it into data lake. You will copy this data into warehouse, and you will run your BI here. Okay, so your BI runs here, and your AIML runs here. Okay, so this architecture, right, it supports to overcome all the limitations, right? What was the limitation of warehouse? You cannot do AIML. So now you can do it in here on this storage tier. You can store unstructured data, which was not possible with warehouse. So all those limitations are being satisfied here or addressed here. You get fine-grained access control through this layer. Now, see, look at it this way: you have two storage tiers. Okay, so you get all the good things which you were getting from data lake, also all the good things from the warehouse also. Okay, you want BI performance, take data from warehouse. You want AIML, you take data from DL. You want to store unstructured data, do it here. You want have fine grained access control, do it here. Okay, so two storage tiers. Okay, so this was the architecture that many people started using. So what were the technology stack, right? You could use a popular ones were, right, a S3 as a data lake plus Redshift. Okay, as your warehouse, or S3 plus Snowflake. This was also very popular because S3 is a data lake plus Snowflake. In Azure world, it was ADLS. Okay, the blob storage plus your Synapse dedicated SQL pools, right? This was the kind of an architecture, right, which was being developed that time. So yeah, this all looked great, right? Like, how do you implement it? The same thing for ingestion, you use glue. Then you do all your basic ETL processing in data lake. But when you do the copy, right, you copy the data into the warehouse, maybe like Snowflake. Then you do your data quality here. You build your the curated layer or the gold layer here, and do BI reporting and all, right? We are going to talk more about the layered approach, the medallion architecture, right, later in this series also. But as of now, just try to understand these things: data lake plus a data warehouse. That's the thing. So we spoke about the advantages, but then this also came with a lot of issues. Okay, so somewhere around 2021, 2022, maybe the dates are not right. It's okay. That is just my experience. But people started and observing these issues, right? What happens with the two storage tier, right? Because this is a two-tier storage, okay? Two-tier storage, I would say storage tier. It is a data lake and a warehouse, right? So the thing is, you don't know where to look for that data, right? Let's say you want to do BI, you have to go here. So business users who wants to do a BI, they'll have to come here. AIML, if someone wants to do, they'll have to come here. Okay. So it is based on the persona, what kind of things they are doing. They have to, go and search the data there. There was also an issue to keep this data in sync. So every time, right, because you're taking the data lake and putting it into warehouse, maybe not everything. Let's say this is 100 TB and you are moving, let's say 30 TB here, okay, but still you have to move that data. So you have to sync that data always, and there you will have to do some extra additional efforts, extra ETL jobs, right? Extra efforts you will have to take to move this data from data lake to warehouse. That is a problem, right? Number one. Second is same for metadata also, right? See, these two are fundamentally two very different storage systems. Data lake uses a cloud object storage. It is right, it works on the principle that you just put the data, don't worry about the schema and all. Here in warehouse, it's very different. You have to be very tightly following the schema and the data types, right? It is the schema on right itself, right? So it has to be properly structured, follow the data types and all. So again, the metadata also, the two places were different, so you had to actually sync that metadata, which was again very difficult, and it's not really possible because these two are fundamentally very different. So let's say you are trying to sync some metadata, you want to bring it here, but there you have not done any data quality checks and all, so that was an issue. So copying the data always, syncing the metadata, looking for data at different places for data, and then still, right here, still there would be issues related to data quality and all. If someone is trying to just access the data from here, there would be data quality concerns here. So those were still there. Okay, it is just that it is a two-tier storage. It is individually they are solving this, right? This is a standalone system, this is a standalone system, but there is no true integration between them. So all these efforts related to um, getting the data in sync, ensuring that whatever data is here, you move it here. It was the other way also. Okay, so if you want to have some data from warehouse to for your AI/ML, you have to move that again data here also. Okay, data lake. So any aggregated data which is required for AI/ML, you have to move that data back to these cases. Okay, so these things were still required. Okay, the other aspects, right, related to warehouse being proprietary format, okay, those were still there. So whatever limitation individually which were there, that still existed. So if you are using a warehouse, here you have to copy the data inside this, which is again would be proprietary. You cannot use any other engine. So those things still existing. So though this architecture was good enough, it did broadly it did solve the issues, right? Like having a better BI performance, right? Having more governance, having the support for AI ML, it did solve those, but still there were issues related to, and that's where the data world was looking for another new pattern where it can solve all these issues, and that's where something like lake house came into picture, a true lake house, I would say. What is a true lake house? When I say, right, there are no two storage tier, it should be a single storage tier, right? This was important, a single storage tier that can do everything. Okay, you don't want to build multiple storage, because the moment you have two storage tier, right, the data copy, the syncing of metadata, right, all those management efforts, all those come into picture, plus manhandling two different systems which are naturally very very different, right? Data lake and a warehouse are very different systems. So all these things were a problem, and that answer for that was a lake house. So in the next, right, lecture, we'll speak more about lakehouse, how it is solving this issue, and what is the best way to implement it. What are the various approaches to do that? Yeah, I think that's it for today's lecture. As I mentioned earlier, also, if you want to try out any of these, I'm giving away some AWS credit, $20 credit. You can try to build these architectures. Maybe in our next few sessions, when we get into more details, maybe that time you can think about implementing these things in AWS. And if you have any other question, if you want to speak to me one is to one, you can always block my time on Topmate. I have some free mentoring slots available there for this month. Thank you, and see you soon.